Now take problem number 64, the last problem of this chapter. This says a small particle traveling with a velocity v, it travels with a velocity v, collides elastically. This has to be remembered. A spherical body of equal mass. That means mass of this, if it is m, mass of this is also m. Although one is big, another is very small. Spherical body of mass m and radius r. Its radius is r. Kept at rest. It is at rest. Now, the speciality of this particular problem, the center of the spherical body, this center, is perpendicularly a small distance d away from the line of motion of the small particle. That means the body moves in this direction, but its center is a small distance d away. And the velocities of the two particles after collision. Now, this small body, of course, will come and hit here. Then what happens? Then, actually, have to consider the center of mass of this body, of this sphere. A center of mass of a sphere is always at its center. We have to draw a little bigger diagram of this sphere. We'll draw a little bigger diagram of this sphere. Now, this is the center line, and the small body, I make an exaggerated diagram, say came and hit here. Right? Came and hit here with a velocity v. Now, this velocity v will have two components. One component will be the center of mass. One component will be through the center of mass. Another component will be tangential at the point of contact. Let us say this angle is theta. Let us say this angle is theta. In that case, if this angle is theta, then this component of the velocity v, this component of the velocity v, if this is theta, or let me put it here, this was v, because vector diagram I can draw anywhere. This was v, this was angle theta. So the component which passes through the center of mass is v cos theta, and the tangential component is v sin theta. So this component is equal to v sin theta. And the component which goes through the center of mass is v cos theta. Now the problem becomes very simple. Since it's an elastic collision, I write over here. Since an elastic collision, and both have same mass, so the component of v, the center of mass, that means v cos theta, will be transferred transferred to the sphere. I repeat once again, why did I say that? Because you remember, if there is a completely elastic collision between two bodies of same mass, then the velocity of the first body is just transferred to the second body. But here, since the collision is not head-on, the component which was through the center of mass will be transferred to the second body. So the velocity of the sphere equal to v, as simple as that. Now, what is cos theta? From here, this is the radius r, this is the distance d. So this much is equal to under root r square minus d square. This is under root r square minus d square. So cos theta is equal to under root r square minus d square divided by r. So this is equal to under root r square minus d square divided by r. And the tangential component does not affect the sphere. Tangential component does not affect the sphere, and the smaller body retain this component velocity. So the velocity of the whole body equal to v sine theta. And what is sine theta? Sine theta is d upon r. So velocity of the small body is v d by r. So these are the two velocities, the velocity of the sphere. This is the velocity of the small body. Though they have not asked in this question, the motion of the sphere will be in this direction, and motion of the small body will be in this direction. And once again, you have seen these two directions are at right angle to each other, right? So this completes the chapter of your, what do you call it? Chapter of collision. So next time, we shall start with the next chapter.